Good afternoon, everyone. I'm going to do it in English if that's okay for everyone. Addressing a shortage of skilled personnel through an innovative skill transferring system. So first of all, what is kind of the issue that we want to tackle here? So I'm going to throw some numbers at you. So 76% of Belgian manufacturers struggle to find skilled personnel. I think a lot of you are probably from the manufacturing industry, and for a lot of you, that will be a problem that you recognize, I think. It's very difficult these days to find the right people for the right job, and it's not going to get any easier because a lot of people are going to retire the coming years. A lot less young people are coming into industry, so it's going to become more and more of an issue. So logically, you would think that the solution for that problem would be that companies start to do more and more training themselves to basically get new hires and take them to be these new skilled people. But 46% of the people in industry, of the companies, aren't actually doing that, aren't training their people to be those new experts. And there's a bit of a gap there. So basically, what is the problem? What is causing this issue? Well, first of all, you have your skilled workforce, and a lot of people are retiring from that and being an outflow of knowledge, of skills from your company. The problem is that new hires, a lot of them are going to the training, but a lot more are these days job hopping, and they are changing from your company to a new company, to new industries, and they are not getting to that skilled level to be those new skilled people in industry. That skilled workforce, normally your trainers that are going to train these new hires would be coming from there, but because they are retiring more and more, there are less and less people available to do that training and to be those new skilled people. So that is kind of an issue, and that is what we are trying to solve with our project now, to try and make sure that you can, in your company, retain these skills, capture these skills, and then use them to make a model and to start training your new hires without the need for so much of your skilled workforce that you needed before. So basically, this is how we are trying to solve this issue, this problem. First, we are going to capture skills. So we are going to define the parameters, what we kind of want to measure in the people, what's important for the skills. So you can think of welding, the movement might be important, spray painting, the same thing. But also skills that are a bit more high level of, okay, what are the steps that I now need to follow? For example, while you're doing brazing, there are a lot of steps that you need to follow and that you need to try and make sure you do in the right order. Then we are going to make a model of these skills that we can then later on use to give feedback to a trainee, to train that person, and to go to the last step, feedback, trying to get, during teaching, feedback to a person and try to get them up to speed and try to teach that skill to them. So we are going to start with the capturing and the modeling. So that's basically keeping the knowledge in your company. So from all those people that are retiring, trying to maintain those skills in your company and make sure that you can use their knowledge to teach the newer kind of generations. Then the feedback system is really more about training more efficiently and trying to make sure that you need less people to do that training and make it cheaper in the long run, basically. So we're going to first look at the capturing. How can you do that? How can you capture those skills of people? And what kind of sensors do you need for that? And how do you set up a kind of measurement session for that? So first of all is, how do you know what you want to record from people, from your experts, from the people that are really good at the skill you want to do? Well, the most important thing is to really start from what we call a contextual inquiry. So it's basically talking to people in your company, so your experts, and asking them, okay, what is now something in this task that you're doing, let's say welding, that is really important to be skilled at this. And usually they can't really tell you of, okay, I hold my hand in this way or I do this or this, but they can usually give an indication of, okay, it's really in the hand movement or it's really in the way that I'm now holding this tool or how quickly that I'm moving. And that gives you some important information in, okay, I'm going to need to be able to measure this. These kind of sensors are going to be necessary. And that's a very important next step, that first step that a lot of companies forget to do a lot of the time. A lot of the time, companies don't really talk to their employees first because they assume that, yeah, they don't really know how they are doing it. It's just something they do automatically, and it's really worthwhile to try and do this. A second thing is manuals. There are a lot of manuals for a lot of skills out there, and usually they also have some indication of, okay, these are important things that you need to measure and need to know because that's really where the skill is in this specific task. So once you have kind of an idea of, okay, this I will need to measure to know and to make an expert model and to know what this person is doing, then you need to start using sensors. And usually we define direct sensors and kind of indirect sensors. So direct sensors are sensors you place on the body of a person and are used to really measure what is their body doing, how is their motion, with hand tracking the same, what is their finger motion. That's important for kind of the grasping. They are using tools in most cases for their skills. So how are they grasping this? Are they pushing a button for a long time? Things like that. Also, eye tracking is an important thing. Eva, the previous speaker, already talked about it a little bit, but that can tell you a lot about where is the focus. Are they looking at a certain thing for a long time? Are they putting attention on something? But also stress level, and that's also very important. Is somebody very stressed while doing a task? The pupil dilation can tell you a lot about that. Then you also have the indirect sensors, and those are sensors that can tell you something about the forces that are being applied. They are usually outside of the person, so not directly on the person. So load cells for force measuring, you can think of force plates to measure the weight distribution of someone. Those are usually a bit more task specific, and yeah, sometimes you will have sensors that are very specific to a certain skill that you are trying to measure. So I'm going to now go through the sensors a little bit and show a bit the options that you have when you're trying to do these measurements. So the first thing is tracking the body. That's something that you're going to use for most skills because, yeah, for most skills it's important the way you move. The ergonomics of something is very important in a lot of skills. Think of welding, think of spray painting. How you hold yourself and how you and the tool is moving are things that are going to define how well you're doing that task. So there are two main systems that we use usually in our recordings. So first of all, IMU systems. And IMU, it's in most phones as well, is basically just measuring accelerations and stuff like that. And that can give you an indication of, okay, what are the velocities, what are the positions of the parts of the body of a person. That would be a suit like you can see over there, basically a bunch of sensors placed on the body measuring all of the segments and how they move. Secondly, you have a marker-based solution, so that would be a camera setup all around the room if you would do it here, with some reflective markers placed on you that will measure what your body is doing, how you're moving, stuff like that. There are pros and cons to both systems. Pros to an IMU system is it's very quick to use, very easy to use, and you don't need anything external. So yeah, it's very easy to implement in like a factory environment, in a production hall. It is less accurate and it's more difficult to track like objects like I would have a table there, I would have parts there. It's more difficult to track those as well with a system like that. With a marker-based solution, well, they are more accurate and they can track objects a lot more easily, but you need a bigger setup and yeah, it's asks a little bit more stuff going around there basically. A second thing is the eye tracking. So we already talked about it gives you an idea of where to focus and about the stress levels with the pupil dilation. For those kind of tracking and stuff like that, there is really one good solution, and that is the camera-based systems that we use. So they are glasses with a camera inside that are fixed on your eye, and they track basically what your eye motion is and your pupil dilation. So they work very nicely. They are very quick to use, usually a quick calibration and you're ready to go. And also very portable for a factory environment and stuff like that. Then hand tracking is the next important thing. So how are you grasping your tools, your objects? What are you doing with your fingers? Again, you have an IMU-based solution. They are also very quick to use, but they have a lot of downsides. They have very limited tracking usually. So for example, the gloves you can see over there, they only track the position of your fingertip. So for some tasks, that's fine, and you can get away with that. For other tasks, that's not really what you want, and you would really like to know the full position of your fingers. That's where one of those flex sensor-based gloves is a lot more useful. They have like very pliable sensors in them that measure all of the angles from your fingers, but they ask a bit more calibration and a bit more setting up to get running. So they also have a bit more accuracy issues because they are measuring all of those angles. Yeah, it's more difficult to get a very, very accurate reading from those kind of gloves. But just to say, there are a lot of sensors that you can use, and this is by no means an exhaustive list, but these are the main ones that we use and that we think work pretty well. And for most tasks, these will give you a very good idea of the skill for your modeling later on. So how does a recording session now actually look like? Because I've listed a lot of sensors, but what does it look like in practice? Well, you have, for example, this person who is doing a drilling task. And what you can see is that he's wearing all of these orange boxes, which are IMUs for the body tracking. We are also doing finger tracking, an IMU solution in this case, and that is for the grasping of the drill. And then we have a load cell over here that is measuring the force of drilling, because you can think when you're drilling, you're applying forces, how hard you're pushing, and what kind of the pattern is that you are applying that force could be important for the skill. And then we also are using glasses to track his eye movement, and also they provide us some point of view information, which is nice afterwards for the for when you're creating a model, basically. Usually there are 3 golden rules where you are trying to take these recordings. When you are recording experts, it's good to record multiple experts, because it's not because, somebody is an expert in something that he is doing it the only possible way. Multiple experts will do things in different ways, and it's important to get recordings of a wide range of them. For a single expert, you should always record him multiple times, so we usually do at least 10 recordings, because even one expert will not do it exactly the same every single time. There are variations, there are just aspects in your motion that are less or more important, for the skill, and it's important to get an idea of that and to capture that. Then you should also always record some people who are bad or very bad or still in training for that skill, so some novices. Because when you are doing the validation of your model, that's very useful. You want to make sure that you know that, okay, I put a novice in there, he's not being classified as an expert, and vice versa. Oh. So for example, and the video is not starting, I think. So this is an example of a recording session in practice, so while it's being done. So this is just a point of view camera footage that you are seeing from the person wearing the eye tracking glasses. And you can see basically with all the sensors the person executing one of those drilling tasks. I think in this case it was a novice, so he's struggling a little bit. But just to give you an idea of what this kind of looks like in practice when you're doing those recordings. This is recorded in the Augment X lab that we have at the University of Brussels, which provide a lot of a very nice environment to do these recordings in. So we've talked about recording, but an important question, of course, is also who do you actually record? Who is an expert? Because a lot of people, when you will ask them in your manufacturing environment, they will say, okay, yeah, I'm quite good at this, I'm an expert. But a lot of the cases, it's not that easy to define of, okay, are you good enough? Are you better than that person? Some companies have some kind of assessment that they use internally that they can use. Not all companies have that. The most important thing there that we also use as a kind of rule is the most important thing is the outcome in the end, right? when you are welding, when you are spray painting, the product that you get at the end is the most important thing. If the weld is okay, then, well, you are an expert. You know, you are providing an end product that is good. So we would like people to mimic what you are doing and get the same results. So it doesn't really necessarily matter if somebody classifies himself as an expert, as long as the end result and the end product is okay, that's fine. And if you want to go further in that, you can work with scales of, you know, in your modeling of this person gets a rating of 4, this 5. So in your model, you can scale it a bit and make sure that you're using a wide range of information. But the most important thing is to look at that end result there. So now we've talked about capturing skills. Another thing is, how do you now create a model of those skills, and you try to use all of that recorded data from those people that you can now maintain in your company and actually use that to train people and to get a model that can give feedback to people of what to improve, where they are going wrong. So what I first want to discuss a little bit is AI is all the hype now, and in this project we don't use AI, and there's a very specific reason for that, and that's explainability. We use PCA, so principal component analysis, in the modeling that we do, because if you would use an AI system, which you can just feed information and you can train, you would need a lot more data, but also in the end it wouldn't be explainable. AI models are very bad at explaining why they take a decision, why somebody is an expert, why somebody is a novice. And if you're training someone, in the end, when you tell them, okay, yeah, what you're doing is not good, you are not doing it in an expert way, what they will want to know is, okay, but what do I improve? You need to explain to them what to change. And principal component analysis is a very nice way of actually giving you that feedback and telling you of, okay, it's not good, but this is what you can improve, this is what you need to change, and then your result will be okay. Which is something that you won't be able to get with AI, at least not with the current AI systems and models that you have. So first, let's go to making a model. So what you will end up with is a lot of data and a lot of information, like what you will see on the left. So these are, for example, recordings for sawing that we did, which is one of the first cases that we tackled in this project. What you will go from there is to basically having a range of parameters that are acceptable. So let's say that you have elbow deviation, so how you are holding your elbow. What you will get is the black line, which is an average of your expert, but you will also get a range around it of the variation that that expert has while executing all of those tasks and all of those trials. So that doesn't mean that, you know, you need to do it exactly on that black line every time. You can change it up a little bit and it's still giving a good end result. That is why you are doing in your recordings those multiple trials with one expert, because you want to know what is the variation there that is acceptable. What you will then get is all of these different models that you can start to score. So basically on the left you can see the model. So those are the gray areas, and you have in blue somebody that is just doing the sawing task, not necessarily an expert, just somebody random that was picked. And you can see that at some parts he is going outside of that allowed range. So over there with the sawing angle, so how he is holding that saw basically. Over there as well with the amplitude, so how fast and how big his strokes are. And then also on the progress speed, so how quickly he is going through that piece of wood that we gave him. And you can see that in the scoring, where normally when he's inside that range, we are giving a score of 1, it very quickly goes down and going to a score of 0. Now, these multiple different scores are very important because that gives you the explainability. In the saw angle, you can see of, okay, at that point, yeah, my sawing was not okay, my sawing angle was not okay, I should change that. I should go higher, go lower, you know what to do, you know what to communicate back. And we'll talk later about how you can do that, communicating back and do the transferring. But that gives you some important indications to who you are training of, okay, change this please. So you can see another example of that over here, of kind of the user interface also that we have for the sawing now. So you can see the different parameters that we are defining there, and also somebody who is very novice at it, that is not doing it right at all. And you can see that there is a lot of feedback being provided there and being given to that user. Now, this is also something that we wanted to test in practice a bit more, and at the Flanders Make Symposium, which is basically a little like machineering, it's a fair. We had a setup where we allowed random people to just do some sawing, and we provided feedback to them based on the models that we have. So you can see somebody sawing here and the feedback that they got, and yeah, we got a lot of positive feedback from that as well, because to a lot of people it was quite clear of, okay, yeah, I should change this, I should try this, and they found it quite useful to try to improve and do the sawing better. Now, another thing I would like to talk about is we talked about recording different experts, and the reason is that different experts will do things in different ways. And the question is, how do you deal with that when you are creating these models? So this is just an example to kind of make the point clear of you have one expert that is going left, you have one expert that is going right in what they are doing data-wise. Well, you could maybe say of throw that into one model, but are you then still training somebody to be an expert or just to be something in between that doesn't really matter and doesn't mean anything? So that's an important thing to kind of tackle. And if you want an example of that, of experts doing the same task in different ways, think of the drilling. You saw the person that we had as an example was holding the drill with his right hand, and on top he was using his hand to kind of push and provide force. What other experts will do is they will provide put their hand at the back, and they will kind of push that way. So that's two very different approaches that have the same good end results, but they are just different ways of doing that tasks. None of the two are wrong, but you can't say, I will throw that into one model, because yeah, then you're somewhere in between, and that doesn't mean anything. No one does it that way. And you will see that in this kind of animation of, if you try to model them together, you will get something in between that really doesn't mean anything. So what we do in the project is we really use a kind of skill library where different experts are just modeled in two different sets, and you can train people according to the model that they already fit the best to. So if you have someone that is already quite close to one expert, well, you train him to be good at the skill according to that expert. If somebody is closer to another expert, well, you try and train him to do it the same way as that expert, because their training path is just a lot shorter that way. So that is a kind of what you see here, a new demonstration. You look at the similarity, and you have a database of all those models of experts, and you see of, okay, closer to this model, let's train you to be like this expert. So now we're going into the final part. You have your model, you want to train people. Now it's time to provide feedback and to try to communicate to that person how to improve. And we use a couple of different ways for that. First of all, there are two kinds of knowledge to transfer here. On one hand, you have the embodied knowledge. So how are you moving? What are the motor skills that you need? On the other hand, you have expert knowledge. So kind of the conceptual knowledge, the knowledge of the procedure of, okay, I am now sawing like this at this angle, but why am I doing this? Or I am measuring this in this way, why am I doing this? The kind of why and the knowledge of, okay, what are the steps to follow? What should you do? So there are two kind of methods that you can use to transfer that, or that we look at for sure. First off is augmented reality. That's quite nice because it allows you to have an actual physical environment and to be quite close to the task that you are trying to teach. So with sawing, that's a task that you can easily mimic in training. With augmented reality, you have the feel of the actual task you are doing it, but you can also have that layer of feedback that you are providing. Another method is what Eva also talked a lot more about, the actual virtual reality, where you have a completely virtual environment. But you need to be careful of, okay, how transferable is this virtual environment to the actual task that you are then going to do. And you can see an example of that in augmented reality of sawing. So you have an expert in red and a novice in blue that are both trying to saw to that board, and the application basically allows you to move around these models and kind of see what they are doing. This is quite an early version still because we are only halfway through the project, so there's still a lot of work to be done. You can also see at the colored bar there that there is one part where there is a red color. That is really where the novice is not doing the task that well. And where we are trying to indicate of, okay, here is a problem. There is difference with the expert. Try to take a look at what the expert is doing differently and how you should change, basically. You can see that the expert is going a lot slower, which might seem weird to you. That is because the expert is actually going a lot quicker through the board than the novice. So we are trying, kind of putting them on the same time frame so you can compare them a bit more easily. But yeah, in reality, he is going through the board quicker. Another way that you can use the knowledge that you recorded is creating activity diagrams. So those expert recordings and from the contextual inquiry, the documentation can be used to create like these flowcharts that are very nice for teaching new people to a skill. They basically allow you to, and this is an example for sawing, which is a simple task it seems, but you know, when you are measuring and when you're doing everything, there can be quite a lot of steps involved. This isn't like the full activity diagram even. And it gives you a very nice graphical overview that you, for example, in augmented reality, can display of these are the steps you need to do, try to follow this. If this happens, what should I change? What should I do? Which is a very nice handhold for the people that you are trying to train. And that you can also try to automatically kind of assess them in if did you follow these steps, did you not follow these steps, which is a very good way of teaching people basically. Another thing, and I think something went wrong here a bit with the text on the PowerPoint, but another thing you can do is you can use large language models, which is also something that is quite a hype now, but for this it's actually quite useful. Basically what you can do, all the documentation that you have, all the expert data, you can feed that into a large language model and you can use that large language model to allow people to ask questions to it. And we talked about explainability. That's also a problem with large language models. But what we have in our models, and unfortunately the quality went down a lot here, but what our large language models do is they give you the sources that they use from the documentation of those companies, of the training data that you provided, so you can verify that what they're telling you is correct. And for example, you could ask them with brazing how to correctly open the nozzle, and they will give you some diagrams, some information on that, which is really that conceptual knowledge of, okay, why am I doing this? How am I doing this? What order should I do things in? And it's a very nice way of giving like an interactive way of providing feedback. They can also give you videos of training videos that you might have in your company. Use those training videos to refer to them and to basically try to indicate certain parts that answer your questions that you are having and your trainees are having. So it is basically what you are seeing here. So what are kind of the next steps for us in this project? So I already mentioned we are only halfway through this project. So the main next steps will be to really improve the feedback and the modeling now. So we already have some basic models that we can use to provide feedback, for example, for sawing, but now we want to move to more complex tasks like welding, like brazing, stuff like that. And also to integrate those large language models into augmented reality, because it would be very nice if you can have augmented reality where you can ask questions to the large language model whilst you are doing the task and kind of improve what you are doing directly through that. So in the project, we look at a lot of different tasks, and I quickly want to highlight kind of what kind of tasks we are doing, just to give you an idea of how broad the kind of training in this kind of way can go. And that there is a lot of different tasks, well, this kind of retention of skills in a company, and then trying to teach them throughout is useful. So these are all cases that were brought to us by companies because they have trouble finding skilled people for them. Brazing is something, but also measurement. You can think of quality control there. Installation of parts, well, really fine finger motion is important, which is something that is more challenging to measure, but with those kind of gloves, you have that option. There is also drilling, which seems like a more basic task, but even there are a lot of things and a lot of parameters that you can consider. Then welding, which is definitely something that there is a lot of trouble for people to find skilled personnel in. And then sawing, which is really the most worked out case at the moment. But I'm sure that a lot of you who are from companies, you probably have a lot of things that you need skilled people in and that something like this might be applicable in. So really the modeling and the feedback is what we are going to work on next. And for the modeling, it's getting a large database and getting ways of really getting that feedback and that assessment going. On the feedback, it's really ways of communicating that to the person and getting those large language models up to an even higher level when you can really communicate with them. So those are the most important points that I wanted to mention. So I really want to stress if there is like anything you would like to do regarding this project or, you know, things that you would like to get involved in or that would be useful to look into, please get in touch also with Tom Tuxen over there, who is from Augmentix Research Lab. We work a lot with, if you need recordings done, it's always a pleasure to work with him. So thank you.